um, obviously one of my favorite things to talk about, not just fungi, but the application of what we've learned about fungi over the years, right? For me personally, it's been a 10-year journey, right? What Angel was talking about, starting out the mycelium block exchange program and then the volunteer events out at Circle Acres, which is a converted brownfield site, right? We turned a 10-acre brownfield site, former landfill, into an educational center. And that was just about, yeah, 8 years ago. But before that, I was traveling quite a bit and getting to know the basics of mycology, right? I come from a background in hydrogeology from UT Austin. I worked oil spill remediation in the massive, giant oil and gas industry that rules North America. And I was an emergency responder to oil spills, so I would get sent out to oil spills within 24 hours and apply my knowledge on hydrogeology and remediation, conventional remediation at the time, to come up with a strategy to deal with the oil spill, right, and the effect of that. So that's my background, and what I'm going to share with y'all today is what of some of the things that I've learned about my experience in the biotech industry, and also outside of that, right? I've done a lot of work, like Angel saying, with the biotech, more corporate roles, and I've also done work more on the community side, grassroots, citizen science efforts. And then most recently, I'll talk more about this a little bit later, but down in Mexico, really combining the two, right? Trying to come up with something that's cleaner, something that's more accessible. In the part of Mexico where I am, fungi are not very well known, liked, accepted. There's a lot of mysteries or a lot of mysticism around them, a lot of uh, cautionary tales, a lot of mycophobia, you could call it. However, with different endeavors, like Angel said again, with Spawn Lab, with Fungi Flora, I've dipped my toes into different ways to talk about fungi and the different uses and applications of fungi. Really quick, Fungi Flora, that's a strictly a fermentation food production project. We make tempeh out of garbanzo beans. So this is a quick fermentation. We have product ready in about 22 hours. So that's more focused on the production of fermented foods. Spawn Lab, for the past, I would say 2-3 years, has been or had been developing R&D. Right now, it's kind of on standstill, but I am going to show you all some of the things that we worked on, which could pave the way for future research, right? So, with all that said, let's get into the presentation. Cool. Can everybody see my screen now? Cool. I see a lot of nodding heads. I'm going to be looking over to this side, to the other monitor, but presentation is going to be running over here. Cool. So I broke up this lecture tonight in 3 parts. Really, it's the journey that I've taken, or at least that I've consistently taken, and one that I recommend to a lot of people. Get out into the field. That's part one. Observe, ask questions. Something that kind of reminds me of Gary Linkoff, which is just get out there, just touch the fungi, even if you don't know their names or even like what they are. Go up to them, get to know their surroundings, get to know their ecology, or at least their behavior, their appearance, right? Share them with friends, take pictures. You don't need any sort of mycological background to do that. Obviously, once what you do with them afterwards, that will require some skill and some expertise and some caution, but it all starts in the field, right? What are we observing? What do we care about? Here's where we're going to talk about things like biodiversity, right? We're going to talk about bioprospecting. We're going to talk about what are some of the characteristics of the fungi that we want to collect or identify or work with or simply record, right? From there, part two talks about the lab. What do we do when we collect, or what do we do with this information that we obtained from the field? And how do we work with fungi, right? This is the real, like, hands-on. Once we have a mushroom, with some fungi or some mushrooms, you don't have a whole lot of time, right? They're gone within, could be hours, could be days, could be weeks, right? These are fast decomposing organisms. Unless you're working with some polypores, then they could last longer and you have more of an opportunity to work with them, to study them. But at the end of the day, it all comes back to what we do in the lab. How do we work in the lab? What are some of the things that we look out for so that we can then take it into the third step, which is how do we develop something out of what we've learned, right? Whether it be in food production and agriculture and bioremediation and material sciences or simply in education, right? For me, my journey started teaching folks about some of these topics that you're seeing on the screen, right? It was my way of diving deeper into the field and at the same time educate those around me so that they could understand what the hell I'm talking about. So it is important to kind of keep these topics in mind, even if you're not, looking to work with enzymes, right? Or stimulate the production of enzymes and then preserve them so that you can then apply them later. Like, even if you don't touch any of that stuff, it is good to know everything so that we can then take an educated step towards innovating, right? A lot of this talk is going to be on innovation. A lot of this talk is going to be on, once we have this information or this experience with fungi, right? Whatever the kind that you may be working with, how do we take that and how do we turn that into something that is going to benefit us, right? That's ultimately what we want, and I think that ultimately that's what fungi want, right? These are sentient beings. These are living beings that have been on this planet for millions of years. Angel mentioned that they've adapted well to this planet, and so there's a lot to learn from these organisms. And even if we don't communicate or we don't have the same language yet, there is a lot that we can learn, right? So I think that there is a deeper message here. When you start studying fungi, when you start working with fungi, they tell you a lot in ways that it's hard. It's really hard to describe, but nonetheless, this is me. If you want to get in touch with me, I am working on my personal website. So if you find yourself clicking this link, you're going to find a few, template information and stuff. I am working on that, but it will have a lot of different projects and breakdowns and galleries and press releases and a lot of the stuff that I've been doing in the past 10 years. And if you want to get in touch with me directly, here's my email, or at least the Mycology's email that I check, a few times a week so we can get in touch. Cool. So let's get into part one. I did want to open up with this. I know it's a lot of information. There's going to be a few slides like this. It's mostly so that you can either take a snapshot, take a photo, or just keep in the background. The main thing that I want to talk to you about here is that the best thing that I've learned, or the main takeaway that I've learned over the years, is that we want to conserve what we already have out there, right? This is something that I got told, or I got asked early on in my career here, which is like, man, it's so awesome that we can do all of these great things with fungi, right? Their enzymatic activity is amazing. We can break down petroleum hydrocarbons, but you know what would be cooler? If we don't have to do any of that, right? If we don't have to step in and clean up our mess, right? This is something that I feel very passionate about these days, which is that there is a lot out there that we can do before we start, going, way into the application side and interfering with technologies that are still in their early adaptation. I'm not saying they're in their infancy anymore because that was 10 years ago, but now they're in their early formats, version one, version two, or a lot of different pilot projects that are very promising. But once we start getting into reforestation, remediation of, large patches of land, and we start interfering with ecosystems, then we have to be very careful, right? Regardless of what we're trying to do. And so on the left, on the text, I do talk about some regulatory and normative work, which I've been getting more into because it is important, right? We look at the work from Fungi Foundation, Juliana and the whole team, and what they've been able to do to elevate the status of fungi globally, and organizations like SPUN and other researchers around the world that are really taking more of an effort into the legal framework and saying, hey, there's a lot that we don't know about fungi, right? And we're not able to keep up with the rate of, deforestation or even just urbanization, right? The more we build, the more impervious cover, the more, more impact we're going to have on the diversity. And at the end of the day, if all we care about is getting the best strains possible of fungi for our individual purposes down the line in terms of application, we still have to preserve, because that's where we're getting most of our genetic diversity, right? I spend a lot of time in the field, and I'm always looking for new genetics, new specimens, new adaptations, different times of the year. And so the best thing that we can do is to preserve where they are, right? This is number one, and I really do feel like we need to emphasize this moving forward. Once we, now that we've established that, we can head out into the field, right? This isn't off limits. Like, we are invited to go out into our nature, right? Into our parks, into even our urban centers. I find a lot of trees, a lot of turkey tail, a lot of reishi growing on trees right in the middle of a busy city, or a busy, or just a sidewalk, and it's breaking through concrete. Those are really interesting scenarios, because we know that fungi have now adapted or have developed a certain ability to grow within that environment, in communication or in contact with everything that's going on around. So this is something that's called bioprospecting, which is, heading out into the field, looking for certain characteristics, not just of the fungi or the mushrooms themselves, but also the substrate that they grow on, the age of that specimen, right? Are there other decomposing fungi that have popped up? Is there a certain sequence in terms of the decomposition, facet of a fallen log, right? So these are all the things that we're looking for. And more than just collecting, right? More than just getting the genetics and the physical specimens, like you're seeing here in the picture on the right. We want to see, we want to interact, we want to understand, some of these things that are happening. And so it's always great to have resources like iNaturalist, these applications that are popping up nowadays. Like, how do we collect and how do we record this information? Because again, with the rate of the climate change and all these other environmental impacts, who knows if next year, that same time of the year, things are going to be the same. There might be a road there, and that suddenly you lost track of where your morel patch was, right? Or your super cool spot to find, Ganoderma applanatum, right? Which nobody else could find. Like, these are all the really cool things that we can do. Here in Mexico, there's also consideration of working with locals, working with communities, right? So there's a whole ethical consideration and a whole line of sustainable practices that we need to apply as scientists, right? We need to develop this bridge to conduct our research in the most ethical way possible, and not just individually, but in communication and in partnership with communities, with the people that have held on to this land, whether they preserved it or simply just or took advantage of it by collecting fungi and working with them. Again, there is a whole regulatory framework behind this, right? There are certain agreements like the Nagoya Protocol, right, which states certain regulations and guidance towards biopiracy, towards patenting, right? Patenting nature and these kinds of exercises, right? From a more biotech, corporate startup culture. These are things that we need to look out for. Again, even if you're not going into this field trying to start a company or trying to start a research lab, these are all things that we need to be looking out for whenever we develop community programs, whenever we come up with educational programs, or simply when we go out into nature, right? Nowadays, there's a lot of fungi-related tourism. A lot of people are going abroad. They're going to places like Greece, to Ecuador, to Bali, or to wherever. And so by going out, into a foreign land, foreign culture, there's a lot of stuff that we need to keep in mind, even if all we're doing is taking pictures or, trying to collect some spore prints or whatever the case may be. There's a lot that goes into it. At the end of the day, bioprospecting comes down to, allowing nature, allowing, these natural processes to become the source of our inspiration for the discoveries, for the innovation, and not the other way around, right? Forcing nature to be a certain way. My approach, and again, I'm not saying that it's right or wrong, but my approach is the opposite. We look to nature for the answers, and then we apply them in the best possible way, whatever that may look like, either following some regulatory framework, ethical considerations, or simply just proper science. At the end of the day, we have to do proper science, ask the right questions, get the right information. So, something like what prospecting may look like is, we go out into the field and we find a particular log that we're interested in, right? Hardwood trees are my particular interest because fungi that grow on these have certain abilities or certain characteristics that I'm particularly interested in, mainly the decomposition of lignin via enzymatic activity. But there's other aspects of these fungi that maybe other people are going to be interested in, right? Like turkey tail. Not only is it a great remediator, producer of these enzymes that are able to modify not just the lignin, but then that can be translated into the modification, degradation, or even just reduction in concentration of certain petroleum hydrocarbons and other contaminants. Uh, Trametes versicolor, turkey tail is also highly medicinal, right? Studies have been done in Asia and in other places that have found that an extract of this mushroom can provide a lot of benefits to our health, right? And even prevent certain tumors and cancers from developing, right? This is all within the same exact log, within the same exact specimens that I'm looking out for, right? So this is what we look out for. We go out into the field, we collect notes, we collect, photos, try to, leave the place as clean or at least as, as less as little impact as we can on the area, right? Um, Down in the bottom right picture, that's on the left is my cousin who lives here and is a biologist doing large scale conservation of land. And on the right is a really awesome friend and scientist, Leif Olson, who's also going to be at the conference next month. We're going to be doing a joint conference, so definitely look out for that. And then, it doesn't hurt to get together with some creative friends and publish a short little manual on what you found, right? This is a project that I did down south. So I'm in the Yucatan Peninsula in the state of Yucatan, and particularly in the capital called Merida. But at the southernmost tip of the state, there's a lot of fungi. We found about 180 different unique species, and then from that, 2 trips out into the preserve, we were able to produce a quick little video, which I'm going to show you. It's only a couple minutes, and a publication that talks about the experience, talks about the fungi that we found, and we even interviewed. Must have been in his 80s, but a Mayan elder, right? Because we are in Mayan territory. Millions of people come from, have Mayan descendancy, and to some degree they've preserved the knowledge, but to a much greater degree a lot of that knowledge has been lost. So every interaction, every communication, every interview is worth a lot. So I'm really happy to have been part of this work over the past few years, and I'll definitely be putting out more work about this. But if y'all don't mind, I'm going to stop sharing this slideshow and then share a quick little video just so y'all can kind of see the work in action. And also, I'll be talking about some of the things as the video plays. It's also just an easier way for me to remind myself of what we're talking about today. Okay. Okay. So, can anybody see the video? Cool. I am speeding this up so that we can kind of go through this. So they invited us out to find these mushrooms or to do a survey of these mushrooms. And in exchange, they let us stay at the preserve, which is really cool. And over the course of 2 trips, we were able to find, what I said, around 180 unique species, right? So we want to look for, or at least in my, for my own interest, I'm looking for the decomposers, right? I actually did go out with a couple of other biologists that were interested in all fungi, and it became a funny situation in which I was just like, there's like, I take 2 steps and I see 10 mushrooms. I can't stop at every single one. I'm look like these, right? These little fungi, growing from the ground. There's so many different varieties, and I was after the white rods. After I was after the decomposers. Um, but here you see some of the things that we do onto the field, right? We want to collect. We want to collect not just the specimens, but we want to collect information about what we're seeing. Once we get into the lab or even just a remote test, we can do things like while they're fresh, especially some of the mushrooms that won't last very long, we can collect spore prints in the field. That's usually first thing that we do, especially with these mushroom producing fungi that have the traditional stem and cap. And if it's something a little bit weirder or harder to get a spore print from, we may even just go straight into getting some tissue into a liquid culture syringe, or just flat out, dry out the specimen so that we can take it back into the lab and be able to do some work with it. So that was a super quick video, just again talking about the contributions of this work to the overall understanding of our biodiversity, all the ecosystems. All this stuff can lead to the development of medicine, new materials, and all these other things that we're going to be talking about. Okay. Right. So this is where what it really comes down to is, going out into the field, understanding, but then doing the bridge, the communication, disseminating of that biodiversity, right? It contributes not just for our purposes in the development of technologies, but also in the appreciation of natural resources, right? It gives you a whole different perspective when you go out into nature for these purposes, right? When you're looking for the smallest things, or even something as really high as some branch up in a tall tree, it gives you a certain appreciation. It can't help but impact you when you're out there and talking about it, right? Once you get back with that information. Okay, now we're going to get into the lab stuff. So I'm going to have some time at the end for questions. Start thinking about what those may be as we go along. We're going to cover a lot of stuff as well. So we'll leave those questions for the end. And yeah, I'll be happy to talk more about any of the things that you talk about or that we talk about here. Okay, so once we make it back into the lab, there's really two types of R&D that, at least that I've practiced, and or it's condensed down to these two types, which is discovery and development, right? Discovery, when we have a new species come in, is what does it do? What is its growth rate, right? What is the mycelium, doing on different media types, right? How does it perform on PDA versus MEA? What if we don't put any nutrition, right? If it's just agar and water, what happens then, right? So there's a lot of questions that we can ask when we first introduce a new specimen into the lab. From there, it really just becomes, what are you interested in? Let's say you're interested in, breaking down all kinds of contaminants. Well, we start doing a whole process of remediation or degradation from a discovery research phase, right? The second type is development. Once we have answers to these basic fundamental questions about, that one specimen, or, after a certain amount of time, we do some isolation, and then we strain isolation and then cultivation. Then we can start asking some tougher questions, which is, okay, now that we know that it can grow on, let's just say, glyphosate, what is it going to take for us to develop that into some sort of field application, right? So that's kind of the big question. And then you break that down into a series of experiments that will lead us to the development of that application, right? So first comes the discovery phase, in which we not only explore the fungus, but also do a comparison to our database or whatever information that you may have already collected from other strains. And then from there, you're able to develop, certain innovations or certain applications as a result of those first few basic questions of discovery. As y'all may see, I'm a big fan of R&D as a driving force behind a lot of these innovations, right? Again, going back into what I said about nature, a lot of the answers, a lot of the information are there. We just have to pay attention. And so that is my favorite thing to do, is to just observe, right? To record, to review the notes, to review the graphs, to review the data, and then from there start asking more and more questions. Obviously, there is a very important topic here, which is safety protocols, especially in the field of bioremediation or microremediation. I feel like this is sometimes left out. Like Angel was saying, like there's an oil spill in your driveway. Okay, well, we throw some sawdust, you collect it, maybe put it into a bin, and you're outdoors. It may not hurt you that bad, but you have to know that you're going to breathe some stuff in if you bring it inside, right? If you bring it into your lab, that may be petroleum hydrocarbons. But down here in Mexico, we've worked with things like pig waste, right, from farms, raw, unfiltered, untreated, just pig waste, all kinds of stuff. And at first, we were just working with it as if it was any other substrate, but we quickly realized this isn't safe, right? We gotta look into what kind of biosafety protocols you need to have in place, what kind of PPE, how do you protect yourself, right? What kind of chemicals are you using, and how are you disposing of that? And ultimately, are you even allowed to do this kind of research, right? Are you even allowed to bring this kind of stuff, right, into your lab? Is it a certified biosafety lab or not? These are the things that I feel are left out of the conversation when we talk about oil spills, or not oil spill, about remediation of toxic contaminants. You're, at the end of the day, you're going to be exposed to these things. And another example is like pasteurizing or sterilizing. Like, okay, if you have plastics, or if you have petroleum, or if you have a particular type of waste stream, the normal route, of mushroom cultivation is pasteurize or sterilize or do something to the substrate to prepare for inoculation and colonization. But how are you going to do that to petroleum based products or plastics, right? How are you going to put that into a pressure cooker? And if you're not able to do that, how are you keeping some sort of control, right, to make sure that your fungi is doing the work and not whatever it picked up along the way? It might be some foreign strain that is actually doing the breakdown, and you're just assuming that because you inoculated it with Pleurotus austriatus that you found the perfect solution, and it may not be the case. The Pleurotus may not do anything. So this is an example early on. This is maybe like 2021 in Mexico. We're working with herbicides, all kinds of agrochemicals, but the main one is glyphosate. And the petri dish picture up here on the left is glyphosate, and on the right is spent motor oil or used motor oil, right? And the same thing. It's different concentrations, either be 10x the application or the suggested application rate, or whatever we may find out into the field in terms of contamination, or something below it, right? And then we do the same thing. This is still part of the bioprospecting, which is, what can these fungi do? Do they grow? Do they expand? This is a zoom in picture of just water, agar, and motor oil. There is no sugar, there is no dextrose, there's nothing. It's just motor oil and agar. And you can see the mycelium did jump, it is running. But again, this is discovery phase. What do we do with this information? How does this lead us to developing strategies for the field, right? Going back into my early hydrogeology days, how can I translate this into a strategy for oil spill remediation when I know that in the industry they're looking for solutions that take 2 weeks, 3 weeks, a month at most? If we're still in the discovery phase, how do we take it to that scale, and how do we make it so that it's competitive with what we're seeing out there, right? These are all the big developmental research questions that at least I've been asking myself for a long time. And I encourage everybody that's interested in doing this kind of work to start getting into the practice of asking themselves, right? From there, right, traditional mycology lab work, right? Who hasn't done at least one of these things, right? Cloning of the mycelium, whether it be from tissue culture, or not necessarily cloning, but cultivating and capturing the genetic variations via spores or spore prints, right? This is stuff that we do in the lab, or at least we can do it in the lab, right? But ultimately, this is the work that we have to do, and it's daily, right? Anybody that's done any mycology work, whether it be for mushroom purposes or whatever, this is a daily activity. So strain development techniques, right? This is the stuff that I teach in the classes and have been teaching for a long time. Is how do we cultivate? How do we not just allow the mycelium to grow, but actually optimize the conditions for growth, right? I mentioned briefly the production of tempeh as a food, right? That's not very different. I used to ferment it in 33 hours, and we're able to break it, reduce the amount of fermentation down to 22 hours as a faster fermentation, because we had to adjust pH and a few other things. And at the same time, develop strains through a selection process, a screening process, so that I identify the best strain of the Rhizopus species that I'm growing, so that I can produce tempeh. Same thing happens when we talk about applied mycology, more from a bioremediation, or at least talking about these types of fungi. Selection is a big part of it. Not all fungi can grow on the same type of wood, not on the same type of waste streams, and so you're going to have to do a lot of screening tests for the selection of desirable traits. From there, it's maintenance, right? Mycelium expansion. I'm sure all of you have heard of Paul Stamets and his book Mycelium Running. It's just a constant thing. It's a maintenance thing. We got to keep up with the mycelium. Again, going back to the regulatory, are you growing fungi that are you okay to grow these fungi, right? Are you growing molds, right? Are you growing things that could eventually lead to some sort of biological or biosafety hazard, not just to yourself, to the team, but also to the environment in case something were to happen? What kind of frameworks, what kind of considerations are you following? What kind of regulations are you following to make sure that that doesn't happen? And after that, it really comes down to quality, right? Mycelium, takes a long time to get mycelium to grow cleanly, not once, but 100 times, 1,000 times, and allow for that to be the same and that to be the standard. So here, the takeaway is that consistency is key, right? Do it often and do it right. And over time, that becomes just secondhand nature to the work that you do, and you don't have to start over from scratch every single time that you get into the lab, right? So these are some of the things that not only have learned myself, but have passed on to students that have attended classes, and also the researchers that I've been fortunate enough to work with, which I'm going to show you all another quick little video that I'm really happy to show. I don't think I've ever shown this one before. I see there's some things in the chat, so I'm going to just go. Okay, and I appreciate everybody's patience. I promise you all this video is not long, and it is worth it. So again, the journey takes us from the field into the lab, and this is what I try to show in this video. Um, it's important to work with not just people that you like, but people that understand that vision, right? People that complement your own particular set of skills, your own expertise, your own interests. So over the years, I've been fortunate enough to work with an interdisciplinary group of people, not just in Mexico, but also in Texas, when we started the Central Texas Mycological Society, it wasn't all mycologists. There are a lot of people involved that were just fascinated by it, but had nothing to do with it. And that allowed it to grow, at least in my opinion, to what it is now. Recruited and I did a call out for designers, industrial designers, for environmentalists, people that are able to communicate the message, or at least able to express the things that maybe a hardcore taxonomist, which we also had in the lab, wouldn't be able to communicate, right? But it's equally as important to merge and to bridge these two kind of expertise. In this particular experiment, you see we're doing a water quality test. We're actually adapting species to salinity. We got contacted here in Mexico to work with
Daniel,
sargasso, which is a seaweed that's
I think that we're not seeing anything on the screen. It's just black.
okay. Oh man, I've been talking over.
Now
I
it
thought you
is.
guys were looking at this. Sorry about that. Let's see.
Like when you
Maybe I
paused
just
it,
clicked
though, it
play and
showed the
didn't share.
picture. When you actually paused it, it showed something. Yeah, now
There.
we can see a plate.
Oh, yeah, it might just be like the loading speed. So it might just be the internet. It's okay. I will have this video at some point online, but let me see.
We try one more time and we'll see.
You can still see the plate.
I can still see the plate.
Not now.
Cool. I'm just gonna give it one more try. Anything?
Um, yeah, we can see it now.
Okay. Yeah. So again, working with different sets of skills is important. Low tech, no tech, high tech. It's all based on what you want to do, what you want to achieve, what you have available to you. This is equally as important, right? To get it right. Sometimes you just have to sit back and answer some phone calls while your team does the work, which is okay. That's what teamwork is all about, and having a team that they can do a lot, even more than I would ever be able to. But I was saying in this particular scene, I don't know if you're able to see it at this point, but we're adapting species in liquid culture, right? So we got contacted to break down sargassum, or at least to work with sargassum, to alleviate the problem that we're facing, at least in this area. But first, we had to adapt the strains to not just the substrate itself, but also the salinity content of that particular material, right? So these are some of the people that I've been fortunate enough to work with. Hopefully, you can see their sweet smiles right now. If not, I will have the video up later. Cool. Thank you all for your patience. Cool. Then another topic for today. Oh yeah, I see in the comments they're saying the video screen is black. That's all right. Okay, can everybody see the screen now? You see the enzymes? Okay, I see some nods. That's great. So another thing that I've learned, in the past, or at least in the past few years, is how important enzyme work and enzyme um, measurement, enzyme preservation is to the whole field of microremediation, right? At the end of the day, we're following the things that fungi do out in nature, and enzymatic activity is one of the big ones, right? It is the central activity from which all of bioremediation, or at least microremediation applications, are based on, right? It is this natural process of fungi breaking down their substrate via the release, the secretion of these enzymes, which again, it's not subtle, right? These are big droplets that you can spot easily with your naked eye. You can collect with a syringe, and ultimately you can measure, right? Um, Again, over the years, I've found that there are specific media combinations for enzymatic production, right? Peter McCoy and his Radical Mycology book has a great chapter on this. Talks about how reishi versus turkey tail, depending on
Hmm.
Uh-oh, looks like we lost Daniel. Maybe a bad connection. Well, we haven't had that happen in a while. Let's give it just a few minutes.
how is that? Hear me
There we
now?
go.
Yeah. Okay. Overload over here. Thank you all for sticking around. Okay. Can we see the screen now? Okay. Cool. Okay. Can everybody see the screen? Am I just talking to myself? I feel like that's happened in the past. Okay, cool. I see some thumbs up. Thank you, Steve. Cool. The last thing I want to just say briefly about enzymes, there's a lot of great reasons to measure and look at the enzymatic activity of a particular strain. But I do want to get into some of the preservation of enzymes. This is quite new. There's a lot of published papers on this, and I do want to encourage folks to look into this. And I want people that have experience with this to reach out to me in particular, right? Um, Enzymes are tricky; they get denatured easily, and so depends, on certain inducers and cofactors, but also pH and temperature, right? These aren't easy, uh, compounds to maintain. However, in the past few years, there are techniques like pelletization, right, to maintain that enzymatic viability and functionability over time. Meaning, there is a certain amount of recovery that at least has been observed in the published articles that I've come across, and I'm happy to share that with anybody that's interested, so that they can be recovered and reused, right? Why do we care about fungi? Again, this is the main, or why do we care about these enzymes produced by fungi? This is the main mechanism that fungi, apply to break down their food sources, their substrates, and ultimately what happens when we expose these fungi to contaminants. So it is important to not only, stimulate or induce the production, measure them, and also ultimately to preserve them for later research or for a full-on application directly with the enzymes, right? And again, this is what it looks like. This is a stimulation. You can, depending on what you're looking for, you may be able to stimulate or induce the production of certain enzymes. They're not subtle. Again, I'll keep repeating that. You can collect them. You can use spectrophotometric uh, measurements or instruments to measure their activity and ultimately get some valuable information about the particular traits that you're looking for, and ultimately screen, right? If you have 40 different strains that you want to screen, this is a quick indicator test to determine which one is more likely going to be able to secrete these enzymes when they get exposed to the contaminant that you're interested in, right? So let's say that I want to, inject this block of, instead of being grain, let's say we want to inject a block of fully colonized, polypore fungus. We want to inject glyphosate to see what happens, what kind of reaction occurs, by the fungus when it gets exposed to the contaminant. Okay, not long to go here. Quickly on bioremediation, I feel like Danielle's going to do like a much better job on this next month in terms of what is it that we can actually do, knowing everything that I just talked about, right? To actually step into the field, right? Whether it be soil, water, air to some degree, but targeting certain contaminants, right? Let's say we want to break down, the used motor, from the used oil from your car, right, that you just changed and it leaked all over. Let's say you want to reduce, the heavy metal concentration of certain waterways. Not going to break them down, they're heavy metals, but you may be able to do some pulling out of solution, and even changing their oxidation state, right? We talked about glyphosate and other, agrochemicals, pesticides, herbicides, right? Synthetic fertilizer. These are things that are being targeted by the application in the field, in situ, by fungi. And again, it could either be aerobic and anaerobic. It could be used to transform and detoxify pollutants, or simply transform those contaminants into new materials, right? And all the while having a low-hanging fruit, which is, waste materials like agricultural residues, sawdust, organic waste, which we can collect. We can go out and get out of, or divert from landfills, and convert into the substrate that we want to use to grow the mycelium, so that we can then develop an application in the field, right? So there's a lot of circularity to this, as you may be able to tell already. And then just to kind of go over the big, innovations, right? The big biotechnological innovations in the fields that I feel strongly about, or strongly about, which are agriculture, education, food production. Obviously, material science is a big one, right? Anything from styrofoam to, all kinds of panels, whatever you may think of. Now there are resources available, anything from Ecovative to even just buying a grow at home mushroom kit, and then breaking that up and putting it into a mold, right? Either Tupperware or plastic containers that you can then shape into a form, right? You may end up with, pots, or you may end up with a lamp. This is a full-on lamp made out of micromaterials. This is shredded paper, right? So there's a lot of things that you can do, even just picking up the closest waste streams to you. And along the way, not only are you going to be educating yourself, but you're going to have the chance to educate others on this. You're going to be able to contribute to the overall knowledge of your experience. If you're, dedicated to actually advancing this, keep good track, keep good notes of this, right? All of these things matter, right? Along the way, doing this work, we realized colonization is no problem, right? With specific substrates. But what happens when you have fully grown, fully myceliated substrate in the shape that you want? How do you take it out of that mold, right? What are some of the best ways that you can do or apply to get out of the mold without breaking up the mycelium, or without affecting the growth of the mycelium, right? There's a lot of trial and error involved in that. And ultimately, you'll be able to develop something that is, beneficial for you and for others. I won't get into medicine too much, but y'all already know, right? This is not new. Fungi and medicine, anything from antibiotics, anything from beta glucans, things that are preventing cancer and other things, to just microdosing, your favorite mushrooms, whatever they may be. Nowadays there's a lot of developments in the medicinal route, and it all starts with, again, the field, right? Going into the field, collecting information, collecting specimens, and then into the lab, so that we develop the skill sets, right, to be able to go out into the field. I'll leave you all with this in terms of application, right? Like Angel said, we talked about I wrote a piece on the block exchange program, collecting these fruiting blocks like you see in the far right from mushroom farms after their second flush, maybe third flush. Um, Nowadays, a lot of mushroom farms have a secondary greenhouse, very passive outdoors, in which they allow those blocks to fruit even more. But then at the end of the day, at some point, it will become a waste stream for the farms. And so it is important for us to at least go out there and collect it. And then we can do some fun stuff like restore, eroded areas, right? This is the landfill cap out at Circle Acres. It was heavily eroded because of stormwater runoff, because of impervious cover, because of urbanization. And so these blocks over time broke down in combination with worms and compost. They developed soil. And then we were able to come in and plant deep rooted grasses so that we stabilize that whole area and then prevent future erosion, right? So these are all things coming from waste streams. Because again, like Angel mentioned with low grow, these farms are growing mushrooms from sawdust, from coffee grounds, right? So you talk about how many times are we reusing that waste stream, right? That would otherwise end up in a landfill. I do want to ask y'all what you think about, the plastic bags. What can we do with these plastic bags? What have we been doing? Like what have people been doing? What kind of innovations can be had from that? Because there is a lot of waste there. And so what can we do with that? At the end of the day, I want to leave you all with this little message, which is, to embrace the transformative power of fungi, right? Whether it be to revolutionize the petroleum, hydrocarbon industry in terms of spill remediation, whether it be, replacing styrofoam and other materials that are currently just not serving us anymore, or to educate others, promote sustainability, and at the end of the day, inspire others and, shape a future that we actually want to be living in. So, with that, I just wanted to say thanks. And if people want to, if folks want to stick around and ask a few questions, I'm happy to stick around. If not, Angel,
Yeah.
you'll be able to do your thing. So,
Thank you so much, Daniel. That was
thank you
so
all.
great. Yeah, let's take a few questions and then we'll do a giveaway of the reishi capsules. So Daniel, I don't know if you have like a fun trivia in mind. We usually do first person to type it in the chat. So maybe while we're taking a few questions. So Justin, do you want to unmute and ask your question? Oh, okay. Yeah. So I'll read Justin's question. So,
Oh, yeah. Yeah.
so he had mentioned that in one slide it looks like the plate had some contaminants. So that's something I'm sure you deal with a lot. And anybody here that does mushroom growing knows that like contamination can happen, but that doesn't mean that we can't still compost those things. And especially if it's a trichoderma contamination, that's really good endophyte for the
I
plant.
mostly identify as a trichoderma farmer. I just want to put that out there. That is the majority of the fungi that I have grown in my time.
Most popular fungus in the world. And so then, Justin, you also commented, I noticed some vessels were with or without O2. Have you found any surprising facultative anaerobes?
For sure. I had a whole another part that was consortium approaches to this work, and I just haven't really refined it enough to present it, but there's a whole another line of work. I was lucky enough in the past few years to get to know a researcher by the name of, oh man, I am not blanking out on her name. I just call her Katarina Turnau from Jagiellonian University in Poland. She's great. So she wants to, she's worked on consortium of species. I'm not there yet. I don't know that many people are, but working, having fungi and multiple species of bacteria and fungi at the same time to, let's say break down whatever contaminant you may be able to find. So that's super interested, and I'm hoping to talk about that later on. I think that for the trivia, just real quick, someone mentioned here plastic eating worms, but what about plastic eating fungi? Can anybody name a fungus that has gained popularity in the past 10 years that can break down plastics specifically. I want to walk into my lab and have all my plastic petri dishes be gone one day, just gone because of this fungus. Can anybody name that fungus?
Oysters.
Oysters are one.
I'll throw
There we
another one
go.
in the chat. Yeah, we've
I,
been giving away. There's some of the folks down at the Meme Lab, and if you guys aren't familiar with the Meme Lab, it's the microgreens and mushroom eatery lab. It's in a shipping container in Cardopia Gardens. So a lot of them, the community in San Antonio, they've been doing all kinds of really cool projects. But Dwayne has been making, and Jason have also been just cloning, and we've been giving away a lot of plastic eating fungi. We'll probably have some at our upcoming events, but if people grow and want to clone it, I'm actually looking for people that want to clone it too. We can like help cover supplies and things like that too. So we just, we don't have like an official lab space in Austin, but in San Antonio, they do have a sterile lab where they can do some of these experiments. But that's one of the things, and it would be fun to try to maybe work with that one and see what we can do with breaking down the bags, the
yeah.
grow bags.
Although oyster, it has been used. Pleurotus has been used. P. microspora is definitely the one that has gained the most uh, reputation, or yeah, I guess fame because of that. I think Shannon has a question.
My question is, speaking to what you were just asking, I know nothing about this. I'm brand new to it. I just was very interested in it. But I do
Welcome.
have a lab, but it's a biosafety level 1 lab. How
Mhm.
much upkeep would something like this take? I've grown a couple of plants in the lab. I think I grew more mold than plants though on Muskog, I think it was called. Petri dishes, and I just don't know what kind of upkeep. I'm very interested in the plastic eating fungi.
No, that's a really great question. I mean, I'll tell you my experience. My first lab was in a walk-in closet. It had a laminar flow hood, a Series One laminar flow hood, which I still have to this day. They last a long time. An all-American pressure cooker, a few petri dishes, and a scalpel, stainless steel scalpel. Um, and that's all you really need. Obviously, you may need some glass jars, but you can get some mason jars. So you can get some grain, in bulk from Wheatsville or one of these local co-ops, and get to work. Right? There's a lot of publications out there. Radical Mycology is one of the ones that I recommend. I see that people asked about books. I always refer people to Peter McCoy's Radical Mycology. It's a great intro, cover to cover on so many different things. It is a nice surface level
Hmm.
overview, but in some things you can dive deeper into it. And at the end of the day, you can always look on. Um, um, I I read mostly publications, so Google Scholar is my best friend, but you can find lots and lots of books nowadays. Alex Dorr also has he has a podcast called Mushroom Revival, and also has a book on micromediation, which I recommend as a starter, and also just general applied mycology. Some of these techniques you can find online. Even folks like William Padilla Brown. Even if you're not interested in cordyceps, there's a lot to learn from his courses, his workshops, and a lot of the content that he posts on YouTube and otherwise, right? So nowadays, these things are accessible.
Mm-hmm. Yeah, I was going to mention too, I listened to I think it's the most recent Mushroom Revival podcast the other day. And the episode was about, uh, and I've seen people sharing this article too about like how to use fungi to kind of decompose an old house, like
Mm-hmm.
construction, like all these, these dilapidated houses, especially through the Midwest Rust Belt area. And so yeah, so this I think it was Red House Studios is the was the guest, the mycologist from that. organization. So he was talking about making materials and some of these concepts. But yeah, there's a lot of good podcasts. I was going to ask too, is there any other, I know we've had a few classes where we've showed people like how to just kind of look at Google Scholar. I know you can kind of get into the weeds there, but it is sometimes if you are really fine tuning your keywords and there's something that you're really interested in, especially like a very specific topic or a very specific fungi, Google Scholar can be a great place to kind of go dig in and really go down the rabbit hole, like looking at what has been done in the past and coming up with your thesis.
And further, just to add to that, follow a particular researcher. So on Google Scholar, there is a great feature, which is you can click on an author and then you can see the whole list of publications that they have, and you can see how that research has changed over the years, because you may have found a paper from 2002, but then that same researcher has published 10 more papers, and then you're reading an older version of that, right? So it's nice to follow researchers, institutions. Like I said, Dr. Katarina Turnau is someone that I've followed, and I think she's amazing in terms of like the work that she's been doing with this consortium of species. And so it's just great to keep track of a particular researcher's line of work, which is more my jam. I did play around with an idea a long time ago of doing something like Genius. There's Genius lyrics online for like songs and whatever, and it allows for annotations, right? So you can actually go into like the Genius portal for a song, and then line by line, you can see annotations in which people are like including links or breakdowns or saying, hey, this feature on that song, or this sample comes from this other song. So you see a lot of information embedded within the text, but all you're looking at is the text itself, which is the lyrics. I thought about that idea with publications, research, publications in which the author of that publication can actually say, hey, I know this methodology is super short, but here's more descriptive step by step, like how did you actually do that, right? Did you shake before extracted, or did you extract and then shake? Like these are some of the things that I think about when I read publications, which is cool. You perform this whole analysis, but what does that actually look like, right? And so that was one of the things that I thought about, and I feel like it could really serve us these days, right? Getting into that, taking advantage of all the publications, and like Angel said, you can easily go down the rabbit hole, but there's got to be more opportunities and more resources for us to bridge the gap between our whatever expertise or whatever level you're in terms of understanding this information, and then the experts that are constantly publishing work, right?
Mm-hmm. Yeah, and there's more and more open journals too. Hopefully that continues, but like Daniel was saying, with like the startup culture and the IP, people trying to create their IP, there's a lot of things that aren't made public.
Mm-hmm.
But yeah, so let's go ahead and do a giveaway. How does that sound? So we have this Reishi Calm capsules from Mushroom Revival, which we were talking about their podcast, which is really great. Definitely recommend it. But yeah, they also have a line of all kinds of mushroom products, tinctures, gummies, all organic as well. So little shout out to them for donating this tonight for our giveaway. So yeah, so Daniel, do you have a trivia question you want to ask? And first person to put it in the chat will be the winner.
Oh, well, I asked about the plastic eating fungi, and it seems like
Oh, okay.
someone answered that.
Someone answered that one. Okay, yeah. And don't include me because I know I think I
or we
Pestil-
could,
Pestilosis.
yeah. So
you got it.
who's do? Who do the do?
Who did?
What it do?
What did you
Let's
do?
see, this is
Some
Dwayne.
Texas humor. Do, are you still here?
If not, I can ask another question, which could be a little bit more challenging.
So do
do is here. Yeah.
are you in Austin or are you out of the area? Because I can send you this prize. I just need to have your address. I might just drop it off if you're my neighbor or something like that. Oh, you're in San Antonio. Oh,
Nice.
Dwayne. Hey,
Oh,
Dwayne.
nice.
Say
We were
hi.
just talking about it.
Yeah. I was like, who's this guy? What it do in San Antonio?
Awesome.
I can't get off mute.
Yeah, say
Ah,
hi, Dwayne, if you can.
Can you hear me?
Yeah, we can hear you.
Oh,
Everybody say
okay.
hi, Dwayne. He's
Yeah, hey
part of the
there.
meme lab and the Myco crew in San Antonio, and he made the plastic eating fungi, which I was talking of.
um, awesome. Well, that works for me.
All right, y'all. Well, I'll send that over. Dwayne, if you can just email the info account with your address, I'll send it to you in the mail.
Sure, thank you.
Yeah.
Awesome. And
Yeah.
if anybody else wants to reach out, I left y'all my contact info. If not, just reach out to Angel and she'll put it together. Really great talking to y'all. I feel like I'm getting back into more of the education, more of the outreach. I'm happy to be up in Texas next month. So if some of y'all are going to be there, like late May 26th is the festival, but maybe a few days before, maybe a few days after, we can get together at Circle Acres or wherever else. And yeah, let's talk
That would be cool.
mushrooms.
Yeah. We're trying to put together a hands-on kind of myco remediation workshop with Danielle. And
Yeah, that'd
so
be
that'd be
great.
awesome. Danielle, let's do this. What it do? Dwayne, get up here too. Let's break it down. Let's decompose together, everybody. In the
Let's
landfill, former
decompose.
landfill.
And let's definitely think more on the plastics, the plastic bags from the blocks. Um, whoever you are listening, if you have any ideas, pitch them to us. You can compress them, you can do other things to the plastic. Recycle is hard, but there's a lot of stuff that we can do. So yeah, like the worms, black soldier fly larvae. There's a lot of things that are out there that could be worth trying. So let's do something. There's resources out there. Let's figure it out, because it could be the next phase of just getting rid of that waste, right? That would be great.
Hey, Daniel, this is Art. I had a quick question or follow up about the
Hey,
plastics.
Art.
And hey, Angel, I've always felt a little weird about having to having to figure out a solution for that. And I don't hear enough people from the mushroom farms talking about that. But what I do see is a tremendous amount of effort and a lot of people putting in a lot of effort to divert this stuff, so-called, waste stream. And the solids, the spent substrates, I mean, those are sort of an issue in and of themselves, just in terms of the amount of mass. We found ways to recycle and reuse those. And the plastics, obviously, not going away and starting to pile up. I've thrown away plastic bags from my spent blocks and like everyone else, but I'm just curious if you've seen any kind of work. I've seen oxo degradable, which is being peddled as a form of biodegradable, but we know that's not the case. Have you seen any kind of innovation happening in terms of either the material that they use for the bag, or just not a bag at all, like a completely different model?
Yeah, no, great question, great point. Definitely, we're looking at it from like, okay, now that the blocks exist and the bags, what do we do with it? The conversation definitely needs to be had, and I've had it myself with mushroom farmers in my classes. Showing people techniques like buckets, right? Like reusable buckets, reusable Tupperware, nursery pots, right? So there's a lot of things that we can do out there, but if you sit down and look at and talk to a mushroom farmer, let's say you bring in Sean and Corey from Hi-Fi Mycology, it's hard from a business standpoint. And again, this is where we have to bridge the gap, even just from the communication standpoint, right? They are trying to run a business, profitable business. Bags make sense to them for whatever reason that may be. Buckets may not make sense for them. And if we want mushroom farms to exist and, do what they do and do it right, yes, it is part of like our duty in a way to educate and to say, hey, we're not going to do that. But there's so many other implications in place, and they may not exist if they adopt a bucket system. We don't know. But yeah, buckets is easy. I don't know too much about biodegradable plastic bags or like replacements. I do know about the ones that you talked about, the OXO. They're not quite biodegradable, but I would go more towards like, Mushroom Mountain, right? So started by Trad Cotter, Olga Cotter, Trad and Olga. That's how I've known them, but there's a lot of changes. Olga is now running Mushroom Mountain. They produce mushrooms in reusable like rough totes from Home Depot, right? Puncture the sides. You have a 50-pound block in there. You're going to have massive flushes. So as long as you're willing to adapt your business to that, if you're following a more traditional route of cultivation, you're stuck with bags, right? That's what's out there. That's what people do. So it's just really up to us to encourage more folks to or at least to explore more options and then educate those folks, and even take it up the ladder and enforce some regulations. Someone's
Talking about Pegasus.
Someone's mentioning unicorn bags. They have biodegradable bags. Pegasus. Let's try it. Let's get some bags, some unicorn bags. Let's get some regular bags.
Yeah, I
Let's
think
see
they'll
what
be.
we can do with
fungi,
with worms and other things.
Hopefully they'll be at the mushroom conference as well. They were there last year. Question that I had, and this is a comment and a question. I'm curious because I have actually looked up on Google Scholar to find what research has been done with glyphosates. But I know that this is just another kind of cool Texas project that's happening at Texas A&M. We have a recording of the class on our YouTube channel. It's from January 2023. We had Dr. Susie Dye, who's from the Dye Lab there. And this has been in the news a lot more recently too, because the EPA is really going after PFAS, or the sort of what we call forever chemicals, which are these, I think like fluorocarbons. I may not be saying that completely right, but like really complex carbons that they're working to use some sort of like silk that's almost like corn silk to like collect them out of water, and then they use this fungi. I can't remember the Latin name of the polypore, but it's a mushroom, or it's a marshmallow polypore. Mm. So it grows here in Texas too. So they worked with the U.S. Forestry Service to do kind of like an experiment in the lab. And you may have done this too, Daniel, where you kind of, and they wanted to measure like the aggressiveness of the decomposition. And so they would do these kind of agar, kind of rock'em sock'em kind of races where they would have, this two agar, the same sort of like matter, and they would put clone basically like this mushroom and see how fast and how aggressive it would be. And then that kind of helped them determine like that. And then looking at the post, I guess it would be the metabolomics, or like looking at the waste after it has been degraded to see what the composition is, like if the actual chemicals were degraded back into kind of like I don't know what you would call it, like into like what soil, or it no longer has these like complex polycarbons.
Yeah, no, I mean it's definitely a whole field, and I've definitely tapped into that. There's secondary products of the degradation, right, that we have to be careful with. There's volatile content as a result of the degradation, right? So this goes back into just the basics of running a lab and being in the lab. Is what are you constantly being exposed to, or what is the potential for you to be exposed to these things, right? You got to think about the worst case scenario. and protect yourself. But yeah, going back to like, super old days of like oil spills in the ocean, right? You can't bring these terrestrial fungi out into the ocean and expect them to do well. You got to have them growing on a substrate that they like, and then that could get flooded and then sunk, and they're not doing anything in the ocean. But maybe you could pool, let's say an oil spill in the ocean, you could pull that out of, the water with a boom, they call them, right? Some of these socks that are filled with sawdust or straw or something, get it out of the water and into land where our terrestrial fungi are able to thrive. So similar approach there. Again, it comes back to to this difference between discovery and development, right? Based on the work that I've done, I've discovered that there's a lot of fungi that are able to break down glyphosate, Roundup, right? These toxic chemicals that are affecting us. But then how do we translate that into some sort of development or to some sort of project that can then pave the way for a better practice, right? So that we can then pitch that to the EPA so that that can become the standard, right? Because it's not enough for us to just have a magic bullet if nobody's going to use it, right? Let's say we come up with a beautiful solution and nobody has access to it. Not only is it too costly, too lengthy, it takes too long to perform. And let's say you're a contractor or environmental consultant hired to do a spill remediation work or project, the EPA may not let you, work with fungi because they're not going to sign off on you closing up that site, right? So this is like a lot of different topics involved in this simple question of like, how do we actually do this, right? And so it takes a lot of conversations. It takes a lot of people to get involved from different backgrounds, different disciplines, to have this dialogue. And that's really what I've learned and what I've gotten to love to do, is become that bridge between academia, community, grassroots, citizen science projects, and then the actual industry leaders, right? The people that are actually doing the work. That at the end of the day, what I've found, putting all the other bad things about corporate America and big industry, but they don't know that these solutions exist, at least some of the times, right? And so we have to present the case for that, right? Speak their language, speak numbers. Again, that may not be for everybody. It barely is something that I'm willing to do, but it's what's needed, right? So how do we communicate? That's really what it comes down to.
Yeah. So if people don't have any more questions, I kind of have a final question for Daniel, because I know kind of as you're talking about all of these challenges and things, it can be pretty daunting. What keeps you inspired and waking up every day with like the fire to like solve these big problems?
I have a question. Oh,
Okay, go ahead, Tommy.
oh, cool. I apologize. This is the first time I've ever used a Zoom before, so I'm trying to figure it out. Hey, Daniel, while you've been down there in Mexico, first of all, what part of Mexico are you in exactly?
In the Yucatan Peninsula, in a city called Mérida.
And my other question is, have you discovered anything that hasn't been discovered yet being down there?
A few mushroom species, yeah, I would say.
Yeah.
There's a few mushrooms that haven't really been worked with, having been worked on or with for these applications, right? Certain
a picture of the flamingo chanterelle, which I'm jealous.
Yeah.
That was on my list. I gotta find that one. I was just in Belize this winter and I was hoping I'd see it, but nope.
So a few strains, some protocols, some methodologies. This is more internal, right? These are things that probably won't see the light of day out in the public domain, but they are based on a lot of different approaches to doing this work. Again, I come from hydrogeology, right? I had to learn how to work with fungi from scratch. Like I studied rocks and minerals and the water cycle in college, and I was able to do that work very well. But then you talk about fungi and spores and mycelium and tissue culturing and enzymes, and it's a whole nother realm, right? So a lot of the methodologies came from not just my background, but also just kind of coming at it from a third kind of like a third person perspective and being like, why are y'all doing all that, right? When we can just simply do this, right? So a lot of these like simple methodologies that over the years have refined further and further. That, you know, that's my training module, right? You come work with me. There's probably like a 6-step training module that you kind of have to go through, from, you know, just working with fungi to sterile work, you know, how to pour some agar, how to, like, these are all the things that I would say I've been fortunate enough to develop. And then, you know, IP for the companies that have hired me, which I'm no longer in hold, like it doesn't belong to me. You know, this is R&D work that I got contracted out to do, and that's great, right? Like, that's the agreement. But again, that won't really come out to any publications with my name on them anytime soon. But I'm really happy about that work. And then just to answer really quick Angel's question, like what keeps me inspired, you know, the fact that fungi allowed me to learn about the world and about, you know, the earth in a whole different way. So I just described what I did in college and in my early years: geology, hydrogeology. Like, this is more of my background. And in fungi, just from the big zoomed out, right, massive geological scales and timelines, right, to fungi just like, oh, this is happening in 2 days, right? This is happening now. We have to like pay attention. And so, yes, the process is fast, but at the same time, it allowed me to slow down and observe the tiny things in nature. And I know that there's so much more to explore. That's one thing, right? Just the fact that fungi can do so many amazing things, the small scale, the large scale, and then there's so much more to be explored. Like, we will not finish. Like, in my lifetime, we will not be done with, you know, observing fungi on this planet. Maybe many lifetimes. And the other thing is, I have yet to come to a stop um, from people, right? Like, people saying, hey, like, everything you're saying is not true. Like, people have continued to be inspired, and people have continued to give me a positive response. And so that to me is enough of a green light to keep going. Um, and at the end of the day, I like them. I enjoy them. I like fungi. I like how quirky they are. I like that they do their own thing. They're not plants. They're not bacteria. They speak their own language, and they kind of do their own funky thing. So those are 3 different reasons why I keep doing this stuff, and it varies from day to day. Sometimes it's just because I got to work and I got to pay my bills, and that's enough of an inspiration. Sometimes it's just, I don't care how much they're paying me. I don't care what's going on. I'm going to go out there and talk to some kids. I'm going to go out there and talk to some people that have never heard about mushrooms, and hope that they can take something away from it. So I would say that's a long, convoluted answer.
That was great. Thanks a bunch, Daniel, for spending your evening with us.
Sure.
And we can't wait to catch up with you at the end of the month next month. Everybody come on out to the Texas Mushroom Festival, and we'll hopefully have an event out at Circle Acres as well prior to the festival that we hope to see everybody at. So yeah, thanks again, everybody, for tuning in. Hope to see you all at the event with William Padilla Brown and everybody else at the Escoffier School on the 27th.
All right. Thank you all.
I'll be
Thank
there.
you.
Bye, everyone.
Thanks, Daniel.
Bye-bye.
Bye-bye.
Mm.